Hey, today I'm present here to discuss about the selection sort algorithm and its analysis. And by algorithm we means that the step of procedures or sequential steps we perform or to do a particular task. For example, to make tea, we have a particular defined set steps which we follow to make tea. And yes, we can say that an algorithm for making tea exists. Similarly, for selection sort, we have a defined uh, a proper algorithm which we follow to sort these elements in a given array. So it is the most basic procedure for selection for sorting. Sorry, we have other procedures also which are very efficient and very better, and they are much better than the selection sort. But as for the beginner, selection sort is the most basic and most uh, it's a good technique. So let's start. First of all, I will tell you what is selection sort basically. In selection sort, we select the index of a particular element in a given array, and then we swap it through the element from its current from that position to sort the array. Basically, we select the element and we are placing it at its correct position by swapping the element which is present at that position. So I will give you an example. For example, I have an array A of 2, 1, 7 and 3, 0, 1, 2, 4. Basically it's of 0, 1, 2, 3 of size 4, and consider that I can have another array B which is currently empty and its index is 3. Okay, now what will I do? That in complete array I will find the minimum element and I will place it in the correct order to get the correct order. 1, then here I can have 2, then 3 and 7. That so what we are doing, find the base minimum element, place it in the B, and further we can transfer the elements of B to A, and finally our A will be 1, 2, 3 and 7. But wait, there's the problem. Every time we are doing this process, we are declaring and defining an extra array B. Although at the end of day we have been given array A which we need to sort. So B is always waste of memory. So to deal this problem, we basically got introduced through different techniques we have today. One of them is selection sort. So let me tell you how selection sort work. So let's consider this array again, and okay, I am introducing another element also. So A 0, 1, 2, 3 and 4. Now it has 5 elements. Now what I'm gonna do, that initially I will consider this element and I will compare this subarray. I'm not comparing, basically I am trying to find the minimum of this subarray, and the minimum value in this subarray is 1. So now so my 1 should not be here, should be here, no, it should be here. So I will swap the 1 with 2. So my answer will be 1, 2, 7, 3 and 5. And now this array subarray is sorted. Now I will go in this array with considering this subarray with respect to this element. Now we can see that nothing is smaller than 2 in this array. So basically 2 is it's in correct position. So we do not need to select. That's why we call selection sort. We don't need to select any element from this. So my array up to this position is sorted now. Now I will consider this part and this subarray with respect to this element. Now 7 and 3, 5. 3 is the minimum of this subarray and 7 is not in its correct position. So we will swap these two. So 1, 2, 3, 7 and 5. and at the last we can again see that this up to this the array is sorted. Now with respect to 7, 5 is smaller, and we will swap these, and our array will be 5, 7, and it's sorted. And yes, up to this, and this we sorted the array. Now I will give you an overview of the algorithm, or we can say pseudo code. So I have been given an array A. Let's consider the same elements we had earlier. It was 1, 2, 3, 4 and 5, 2, 7, 1, 5, 3. Okay, so in the process, what will I do? First of all, I will traverse the array I is equal to 0 to n minus 1. Then I will assign each I which to minimum. And why I want minimum? So that I can get the index of minimum element of any subarray we are considering. We will further look it. That's what I want to say. Then after that we have j is equal to I plus 1 to n minus 1. And if array at minimum is greater than array at j, then my minimum will be assigned with j, and this loop got closed. For loop will be closed here, and it's my okay. And if I is not equal to minimum, then I will swap array of I and array of minimum. So that's the complete code we'll be looking. So okay, I will explain you what it means. So let's go through the simulation of the program, that what will it do if an array of these elements is encountered to the program. So I will have I from 0 to n minus 1. Now I will go from 0 to n minus 1. Now my I is from here, and my j will start from here. Now why I am placing j ahead of I? Because every time I am dealing with the sorted array, my sub-array will be ahead of the sorted array. In first case of a sorted array is just one element, because an element to itself is always sorted. And my sub-array is the complete array except the element 2. So my j will be ahead of I. That's why it's been having I plus 1. Now I am giving minimum as the index. We are not sure that what will be the index, so we will have to traverse through all the index of the array. Now if array of minimum is greater than array of j, then j will be assigned to minimum, and we will get the index of minimum element as. And if minimum and I are not equal, so let's consider now in this subarray we are having I as 0 and j from 1 to 4. For I is equal to 0, j will go from 1 to 4, and we see at j is equal to 2, array at minimum is greater than array at j. Here that array at minimum is greater than array at j. So my j will be assigned to minimum. So my minimum will become 2. So 2 is my minimum. And then we see that I and minimum are not equal. I is 0 and minimum is 2. So we will swap these two elements and my resultant array will be 17253. And my array up to this portion is sorted. Now I will consider this part with this subarray and with this element. And now 7 is greater than 2, 5 and 3. But the minimum element is 2. So my minimum will be assigned to 2 again. And this procedure continues till our complete array gets sorted. Now we will discuss the analysis of this process. This process is not that much efficient because to every case, whether it is worst case or it is best case. Now what is worst case and what is best case? Basically, how fast our algorithm works. If all the elements are in decreasing order and we want to sort them in increasing order, then in that case it's not a good technique, because every time we will be swapping. At every iteration of the for loop, swapping would be required. So, and it varies as O of n square. And what is this? This is the complexity, which means that if our program is starting, then the time complexity will be according to the square of number of inputs provided. And how we reach to this decision? Now let me make this clear to you. For n elements, n minus 1 checks are done. N minus 1 checks. And what checks are these? What are we checking? That is to find minimum. So basically, if n elements are given, for example, here we were 5 elements. In 5 elements at starting we were checking 4 elements to find minimum. And when one of my element got sorted, the rest array will be having n minus 1 elements. And in these n minus 1 elements, n minus 2 checks are done to find minimum. Therefore, the complete complexity or time involvement or number of checks, we can say. So our calculation of efficiency of program will depend on the number of checks. So we will have n minus 1 plus n minus 2 plus n minus 3 up to 1 when only 2 elements will be left at the end of the program. And this is an AP. We can see that. And how it will be calculated? N minus 1 into n minus 1 minus 1 upon 2. We know the SN formula. If we have same common difference as 1, and it will be n minus 1 into n minus 2 by 2. And it comes out to be 1 by 2 and n square minus 2n minus n plus 2, which is n square minus 3n plus 2. Now asymptotic notation tells us that when our input size is very large, then we ignore these terms and the constant. So our complexity is O n square. And for worst case, best case, average case, it is O n square. Thank you for watching. If you see that my discussion and my explanation was efficient, then please give me a feedback so that I will give you further sorting algorithms and their efficiency also. I'm also thinking to give other tutorials for any topic which you are finding difficult. I hope this was helpful. Thank you.